All right, guys, so welcome back from the interruption of the Zoom. All right, so as I was saying, you should be able to see how we get AD to be equal to C sine B, because that's what I just worked out for you. All right, now if we are to use so we use the left right angle triangle when we were calculating AD. So that's what we did first. We used the left right angle triangle. So we started A to B and B to D. And then we go back to A. Now, if we now calculate the same AD by using the other right angle triangle. So instead of using the left right angle triangle to calculate AD, now we are using the right angle triangle on the right side. All right. So with the same scenario, we could use now angle C. So if we use angle C, so this would be angle C, and we apply the sine ratio just the same, then we would have the sine of C, sine of the angle C, is equal to, which side is opposite to the angle C now? So AD would also be opposite to this angle C. So we would say AD over the hypotenuse of that angle, which is B. So that would be over B. And as before, we want to make AD the subject. So we bring B across and multiply by B. So we will get B sine C would be equal to AD. All right, so what we see here is that AD is also equal to B sine C. So AD equal to C sine B, right? AD equal to C sine B, and AD equal to B sine C. Everybody see that so far? Is that clear? All right, so if that is clear, let us continue. So what we have here then, we have AD having the same value. So what we can do then, we could now equate, and let me write that too for you. We could, since AD is equal to C sine B and AD equal to B sine C, that means C sine B is equal to B sine C. So we can say C sine B I have to be real patient to write with this thing. C sine B is equal to B sine C, because both of them equal to AD. All right, so now what we can do a little arrangement. So we could now move this sine C from the right hand side and bring it to the left. But remember now, the rule with equation, if you're multiplying by some number on one side of the equation, you can take it to the other side and do the opposite. So if you're multiplying on the right by sine C, you could take it to the left and divide by sine C. All right. So if we move this to the left, we will get C sine B divided by sine C. And that would be equal to B. All right, so we can do the same thing now. We can bring this sine B up in the numerator on the other side and divide. So we bring it down on the other side and divide, since we are multiplying it by C on this side. So now we would have left C over sine C on the left. And on the right now, we would have B over sine B. All right, so here you are seeing how the sine rule is coming about. Now for a similar triangle that we are using here, and if we are working with the side A, we would get that to also be equal to A over sine of the angle A. All right, and so this is what we refer to now as the sine rule. Although it is in a backward sense, it generally starts A over sine A equal to B over sine C, sorry, B over sine B equals C over sine C. All right, so this is how we get the sine rule. So in other words, this is our proof of the sine rule. All right, so just to show you, that's how it would look. And if we use another triangle, we could get that to be the same. And so we form the equations. And so this is what the sine rule is. So the sine rule is A over sine A equal to B over sine of the angle B equal to C over the sine of the angle C. Now, remember I said to you that we don't use all three fractions or three ratios when we are doing this using the sine rule. We're only going to use two at a time. Like what we have here, if we were working with the side B and the side C, we would use the ratio B over sine B equals C over sine C. Or if we are working with A and C, we'll use A over sine A with C over sine C. All right, guys? All right, so with that said, let us see how we apply the rule to a question. All right, so here we have a written question. Now, one of the things that you would be already familiar with from we were doing right angle triangles is how to construct our triangle. Now remember now, these triangles that we are constructing, they are not right angle triangles, but rather they are scalene triangles. All right. So for the construction, we are given the angle A, we are given the angle C, and we are given the side B. So we are only given 3 elements of this triangle. So we have to draw a diagram representing what we have. So we have the angle A, we have the angle C, and we have the side B. So those are what we are given. And if you recall from the conditions that were given for the sine rule, remember we say that you can be given 2 angles and 1 side, or 1 side and any 2 angles, right? So this condition works with the sine rule. Now, what are we doing here? We are solving the triangle. And when we are solving the triangle, if we are given 3 of the elements, then we have to solve for the other 3 elements that we don't know. So it means that we don't know the angle B. So we'll have to solve for the angle B. We don't know the side A. So we'll have to solve for the side A. We don't know the side C. So we'll have to solve for the side C. All right. Everybody is following so far? Any question? All right, so what we can do, what is pretty much the easiest thing to solve here would be for the angle B. Can you solve for the angle B? Can somebody calculate and tell me what the angle B is supposed to be? Can somebody tell me how we can solve for the angle B? Guys, I'm waiting. This should be pretty much a 1, 2, 3 situation. As you remember, we have already learned some properties about triangles. And
Sir?
Yes, go ahead, Mr. Lamar.
How do we find angle B?
Yes.
Sir, we can add the 2 known angles and then subtract that from 180 degrees.
Exactly. So in that sense, can you just do a quick calculation and give me what angle B will work out to be?
Yes, sir. Sir, the answer is 66 degrees.
66. Everybody see that? So we could just add we know that all the angles in that triangle will add up to give you 180. So if we know 2 of them, we just add them and subtract from 180, and then we will get the other one, which is 66 in this case. So angle B equal to 66. So that would mean that we would have solved for one of the unknown elements already. So that would leave us with the side A and the side C to solve for. Now, to solve for the side A and the side C, it is not as straightforward as solving for the angle B. Here is where now we will have to use the sine rule. Now, how can we use the sine rule here? Now, we have to use the sine rule with an angle and a side that we already know. So we have to look for an angle that we know and a side opposite to that angle. Now we have just calculated angle B. All right. So angle B would be 66 degrees. Let me put in that. So angle B here is 66 degrees. Now what we know the side opposite to the angle B. That means we know the side B. Now the side B is 61.8 degrees. Now let's say that we either now want to solve for the side A or the side C. So we only can solve one at a time. So let's say that we are solving for the side A. Then we'll have to pick out from the sine rule A over sine A with B over sine B, because we know the side B and we know the angle B, so we have to use that one in the equation. So whichever one of them you know the side and the angle of, right? The opposite side with the angle. Once you know those, you have to choose that one in the equation. All right. So if we're going to solve now for the side A, then we have to put the side A over the sine of A. So we have to use this part of the rule that says A over sine A is equal to the side B over sine of the angle B. All right, so now if we write this out, it means that we are trying to solve for this A. We want to find this A. So we don't know what A is. We know what B is, the side B is. We know what the angle B is. We know what the angle A is. So we put in what we know. We don't know A, so we leave A as it is. So we put back the A, but we know the angle A. Now the angle A is 42, so we're going to replace A now with 42. So we're going to have sine of 42 degrees. Now this must be equal to B, which we know. B is 61.8. Now you don't have to put in the units in your calculation, but put it back in your answer. All right, so 61.8, that is the side B, over the sine of the angle B. The angle B is 66, so you can use sine of 66. Now, what is it that we're really trying to find here? We want to find the side A. So all we have to do is make A the subject by leaving A by itself on one side. So we don't want the sine 42 on the side where the A is. We want the A by itself. So we're going to move this sine 42 to the right-hand side. So it is dividing on the left. The sine 42 is dividing the A on the left. So when we move it to the right-hand side, it's going to multiply what we have in the numerator. So if we rewrite this equation, we would have A now A is equal to, now we're going to write back the 61.8. Now we're going to move this sine 42 across and multiply it by the 61.8. So that would become 61.8 times sine of 42. And now we are dividing by the sine of 66. Now, once you have done this arrangement, this is pretty much a one-shot calculation. So what you do, find the sine of 42, then you times it by 61.8. Then you divide what you get by sine of 66. You can do that in one shot with a calculator. But if you are not comfortable doing it with the one shot, find the sine of these values first, put them in, then do the calculation. So can somebody do that and tell me what you get for your answer? Anybody working that for me this way? Some are you working it? Mr. Lamar, those of you
Yes, sir.
do the calculation for me, please.
So the numerator is 41.35.
41.35 divided by
0.913.
0.913. And when you do that calculation, what you get?
So so 45.29.
45.29. And this now, we're going to write it back with the units. So that would be millimeters. And this would be the value for A. All right, guys. Now, so after we have found A, then the next element that we have to calculate would be C. And so we would do C, we would calculate for C in a similar way. We would put the side C over the sine of the angle C. So what this rule would work out to, since we are finding C, we could say C over the sine of the angle C. Then now what we need to do is use one of these. So we could use what B over the sine of B, because we know that side and we know that angle. Or we could also use the side A over the sine of A, because we did calculate the side A and we know the angle A. So whichever one of these you want to use. But since you're working with B over sine B already, let us work with that. So we would have B over sine B. All right, and then now, just as before, we would put in what we know in this equation. We don't know C, the side C, so that we have to just rewrite back that. That's what we're trying to find. But we know what the angle C is. The angle C is 72, so we write the sine of 72 down here. And that will equal the side B, which is 61.8 over sine of Lamar, can you mute? All right. So that would be equal to 61.8 over the angle, the sine of the angle, 66. And then as before, because we are calculating for C, we would make C the subject. That means the sine of 72 here would have to bring it on the other side and multiply in the numerator. All right, so let me just separate this. So then we would have now C is equal to 61.8 times sine of 72 divided by sine of 66. All right, so once again, Mr. Lamar, you can go ahead and do that calculation and tell me what you get.
Okay, sir.
So what you get for the numerator?
Sure. So the numerator is 58.77.
All right, so the numerator is 58.77.
The numerator is 0.913.
All right, so just as before, because once it says same 0.913, you would have here. And that is even one of the reasons why it makes sense to use that because you would already calculate these values for sine of b. Now, when you divide the numerator by the denominator, what you get?
64.37.
54?
64.
Oh, 64.
0.37.
64.37. And so this would be in millimeters. Don't forget to put back your units, guys. All right, so that's how we actually apply the sine rule. All right. So is it clear to everybody what we are doing? All right, so I'm just going to clear what I have here. And then now I'm just going to just quickly go back through. So we calculate this, the angle B, by adding up the two angles in the triangle and subtract them from 180, we get B to be 66. Now we want to find the side A and we want to find the side C. So we can use this equation, and here we are calculating for A. And so we can write it in this way. And then now we, as you notice, we would move the sign of 42 on the left and times it by the 61.8. And then now we work that out with our calculator, we get 45.3 millimeters. So that would have been for the side A. In a similar way, we work out for the side C. So we say C over sine of 72 is equal to 61.8 over sine of 66. Making C the subject, we bring sine 72 on the right-hand side, times it by 61.8. Calculate the numerator, then divide by the denominator, we get 64.34. Was that our answers that we were just working with, Mr. Lamar? So our solution then to the triangle, we would have calculated the angle B, 66. We calculated the side A, which is 45.3, and we calculate the side C, which is 64.34. Now, sometimes you may have a slight variation with the decimal based on
maybe because me never put in what I decimal places them I go to.
Right. So I was just saying based on how you round off. So if you use all the values that appear on your calculator without rounding off, you will get a more accurate answer. So that's why I say it's best when you do a one shot. So you would have multiplied the numerator. In this case, you would say 61.8 times sine 72, and then divide by sine 66. You can put in all of that at once in your calculator. And so you wouldn't have to do any round off, but you could just round off the final answer. All right, Mr. Lamar? So rounding off will affect how the decimal places work, or the best approximation for your answer would be to put in all the values, calculate them without rounding off, and in your final answer, you do your rounding off.
Yes, sir.
If you do the numerator first, then round off, then you do the denominator, then round off, then you divide, you're going to have a slight difference in what you would get if you had done it in one shot. All right, guys? Any question? All right, so remember we said that there are two conditions when we're applying the sine rule. So this condition that we had, we were given two angles and one of the side. Now we have another condition which you can also get, but you would have applied the rule in a similar fashion. Now the sine rule can also be used when we are dealing with the diameter of a circumscribing of a triangle. What does that mean? Circumscribing of a triangle means that you're drawing a circle to enclose a triangle in the circle where the circumference touch all the vertices of the triangle. So this is a triangle, and this is when you circumscribe it, you put the circle and it touches all the circumference, touches all the vertices. If you have a situation like this, you can also use the sine rule to calculate the diameter of this circle. All right, so the sine rule says that A over sine A equal B over sine B is equal to C over sine C, which is equal to D. So all you have to do to get the diameter is take one of these ratio. So you could use A over sine A, say find with a known side A and a known angle A, you could divide the side A by the sine of angle A and you get the diameter, just as simple as that. All right, so that's how you would use that. So in this example, they say find the diameter of this. So you have this, the side B, which is 112. You know the angle B. So you could use B over sine B to calculate your diameter. All right. So B over sine B would be equal 112 over sine 42, which is equal to 171. All right, so I think that is pretty straightforward. Any question so far, guys? All right, so with that said, let us move on now to the cosine rule. Now, the sine rule is pretty much easy to remember than the cosine rule, because the cosine rule comes with 3 parts to it. You will have to really become familiar with the cosine rule. All right. Now here we have a question says that in the triangle ABC, the side A is equal to 70, the side B equal to 40, the angle C is equal to 64. So let us put in what we know. We know the side B, the side A, and we know the angle C. Now, this condition, if you pay close attention to it, would be one of the conditions for the cosine rule. So what you're given here in this condition, you're given 2 sides, and you're given the angle between the 2 sides. So remember, once you have this condition, you're going to be using the cosine rule. Now, if we are solving this triangle by the cosine rule, what it means, we only know one angle. So it means that we don't know the angle A, we don't know the angle B, and we don't know the side C. So these are the other 3 elements that we have to calculate in order to solve this triangle. All right. So in the 2 scenario, when we're using the sine rule or the cosine rule, we are generally using the rules to solve the triangle. And so generally we're going to have 3 elements, and the other 3 elements we have to find. All right, so in this case, if you apply the cosine rule, we would choose that part of the rule that starts off with the side that we don't know. So the rule comes in 3 parts, right? And I should just take a quick, let me just go back quickly to the rules of the cosine rule for you to just become familiar with it, and then we get back to this question, because I really want you to grasp the concept of the cosine rule. All right, guys. So let me clear this, and I'm just going to race back to the slides of the cosine rule. All right, so here we are again. So that is the sine rule. But this now we have the cosine rule. So here the cosine rule in 3 different equations. All right, so let me explain how we use the cosine rule. All right, so generally, if we look closely at the cosine rule, we would see that the first part of the rule would resemble Pythagoras' theorem. So that's one easy thing about the rule to remember. Now, the second part of the cosine rule, we always have a -2 after the first part. Now, we have 2 letters represent 2 sides beside the 2. Where do we get those 2 letters from? We get it from the side where you have the plus, the 2 squares. In this case, you have b squared plus c squared. So you take the b and the c, the same value, and put it beside the 2 here. Now the angle here going to be the angle of the letter that starts the rule. So A starts the rule, so you're going to find the cosine of the angle A. On the other side, you have b squared plus c squared. You must have minus bc. Now, if you look at the other equations in the rule, you will see that they follow the same principle. All right. Looking at this one here, we have, it starts off with b squared. So we're finding the cos of b on this side. We notice that if we write it as Pythagoras' theorem, b squared is equal to a squared plus c squared. Then on this side, we have a squared and c squared. So here we must have a minus ac, right? And then now the cos of the angle b. Likewise with this one, if we are starting off with c squared, on the other side, we're going to have a squared plus b squared. On this side, we're going to have minus AB. And then we're going to have cos of the angle C. All right, so that's some key things to note about the rules. Now, how do we really apply the rules? Now, the rules are applied based on the side that you're trying to find. Now, if you're finding the side C, then you're going to write the